Hello and welcome to Turbo Mind. Today we embark on an extraordinary journey as we delve into the realm of near-term human space exploration. Join us as we explore the exciting possibilities that lie just beyond our atmosphere. While the vastness of the cosmos beckons us, our first steps beyond Earth are within reach. The relentless pace of technological innovation is finally allowing humanity to set its sights on expanding beyond our home planet. Let's explore some of the exciting technologies and ideas that could shape our future in space. The Moon, our celestial neighbor, holds immense potential for near-term human exploration. With initiatives like NASA's Artemis program, we're poised to return astronauts to the lunar surface. This time, however, we aim to establish a sustainable presence, utilizing the Moon's resources to support long-duration missions and test technologies for future deep space exploration. The proximity of the Moon to the Earth has made it the perfect starting point for our first tentative steps beyond the comfort of the Earth. This means shorter travel times and minimal lag in communications with Earth, helping make setting up and maintaining the settlements much more plausible in the coming years. The discovery of water ice, which is located in craters at the lunar poles, allows for the local production of water and the creation of rocket fuel, both of which help reduce the need for expensive launches of these heavy resources up from the surface of the Earth, thus increasing the commercial viability of such projects. Once this infrastructure is in place, these lunar settlements will then be able to grow rapidly and support more and more permanent colonists, and also shorter-term visitors. That's right, your dream vacation might be possible sooner than you thought. But our aspirations don't end with the Moon. Mars, the red planet, tantalizes us with the possibility of becoming a multi-planetary species. Several space agencies and private companies are actively working on ambitious Mars missions, aiming to send humans to the red planet within the next few decades. These missions will test our endurance, ingenuity, and the limits of human exploration. We will use our experience and technology gained from our lunar projects as a basis for our initial Martian base. However, Mars will provide a challenge way beyond that of the Moon. The communications delay back to Earth, which is between 5 and 20 minutes one way, means Martian colonists are more isolated and will therefore need to be much more self-reliant. No instant answers or instructions from specialists back home, and any emergency resupply will take months. The weather on the red planet gives us another challenge to overcome. Frequent planet-wide dust storms affect communications systems and render solar panels nearly useless. This means alternative power sources will be required, most likely, large-scale radioisotope thermoelectric generators, or RTGs, similar to those used on the Curiosity and Perseverance rovers. Radiation is another significant concern for the new inhabitants of Mars. The lack of any significant magnetic field means there is no protection against harmful galactic cosmic rays. One way to reduce this risk is to set up our settlements in caves or lava tubes, putting thick rock walls between people and the source of this radiation. Despite these challenges, Mars is the obvious choice for our first tentative steps beyond the Earth-Moon system due to its relative proximity. In the red dust of Mars, we will become a two-planet species at last. Looking beyond the rocky planets, near-Earth asteroids also provide intriguing opportunities for human space exploration. These cosmic wanderers contain valuable resources and offer a chance to study the early days of our solar system. Asteroid mining could revolutionize our access to precious metals and rare minerals, while providing the resources needed for long-duration space missions. It has also been suggested that asteroids themselves may provide a great opportunity for humanity to create settlements. A space station like Habitat, which has been burrowed into the center of an asteroid, would be protected from external radiation and would be well placed to make use of the resources surrounding it. It could slowly mine the asteroid enveloping it, using the conveniently placed metal and mineral supply to expand and grow the settlement. As we look further out into the solar system, we come across the Jovian system and its collection of natural satellites as another potential destination. Colonizing the moons of Jupiter would require a bold and visionary approach. First, we would need to send robotic missions to extensively survey and study the moons, identifying potential landing sites and assessing their geological and environmental characteristics. This data would guide the establishment of initial robotic outposts, paving the way for human missions. To ensure the safety of colonists, we would develop advanced radiation shielding technologies and design habitats capable of withstanding the extreme cold and rugged terrain. Resource utilization would be crucial, with water ice being a valuable asset for sustaining life and generating fuel for propulsion systems. Self-sustainability would be a primary goal, with colonies equipped with sophisticated life support systems and advanced recycling capabilities. As colonies expand, the construction of underground habitats could provide additional protection from radiation and harsh surface conditions similar to those we discussed creating on Mars. Continuous advancements in robotics, artificial intelligence, and 3D printing would enable the development of infrastructure, mining operations, and the establishment of sustainable energy sources. Collaboration between space agencies and private enterprises would be paramount, pooling resources, expertise, and funding to realize the grand vision of human colonization on the moons of Jupiter. The proximity of these moons to each other could allow for a constant flow of people and resources between large habitats set up across the Jupiter system, allowing each to grow more quickly. This could result in an established industrial economy within the Jovian system. Additionally, advancements in propulsion technologies are revolutionizing our ability to reach distant destinations. Ion propulsion, nuclear propulsion, and even breakthrough concepts like the M-Drive are pushing the boundaries of what's possible. These technologies offer the potential for faster and more efficient travel, reducing the time required to reach the destinations we have discussed, but also allowing us to venture further to the outer solar system and beyond. We will also accelerate the development of space stations, which will play a crucial role in our near-term space exploration efforts. These floating outposts will serve as stepping stones, providing a platform for scientific research, testing of life support systems, and refining the technologies needed for deep space missions. NASA's Gateway and commercial ventures like the Axiom space station are paving the way for a vibrant space infrastructure around the Earth, although this technology will be developed to allow us to thrive almost anywhere in the solar system, planet not required. And finally, as we embark on our near-term space exploration endeavors, we must acknowledge that international collaboration is vital. Space agencies, private companies, and nations must come together, sharing resources, knowledge, and expertise. Collaborative efforts like the International Space Station have demonstrated the power of cooperation in advancing our exploration capabilities. In summary, the era of near-term human space exploration is upon us. The Moon, Mars, asteroids, and beyond beckon us to venture further into the cosmos. With advancements in technology, propulsion, and habitat development, we are poised to make significant strides in the coming decades. Thank you for watching, and please remember to like and subscribe.